Dear students, welcome to mathematics online classes. In this class, we will study the concept of product of two vectors. Product of two vectors, here two types of products we will study. One is scalar product of two vectors and another one is vector product of two vectors. Under that, first heading is scalar product of two vectors. Scalar product of two vectors. Scalar product of two vectors and another one I told you vector product of two vectors. With itself we can think of one thing, scalar product means product of two vectors will result into a scalar value. Scalar value means any real value, and vector product of two vectors means product of two vectors will give us a vector again. Yes, now first one we are going to take a scalar product of two vectors. Scalar product is also called as a dot product of two vectors. Scalar product or a dot product of two vectors or dot product of two vectors. What do you mean by that? Say, suppose there are two vectors, vector A and vector B. Like this, there are two vectors and theta is the angle between these two vectors A and B. Now here dot product of two vectors will be represented as A dot B, like this. Dot product of two vectors or scalar product of two vectors will be represented like this. This is equal to magnitude of vector A into magnitude of vector B into cos theta. This is the definition of product of two vectors. How will you write it? We will write it like, let A and B are two vectors. Let A and B are two vectors, and dot product of these two vectors represented as A dot B is defined as A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. So, and with this we can say here theta is angle between vectors A and B, angle between A and B. This is must and should. And what can be the theta range? Theta range can be 0 less than or equal to theta less than or equal to pi. So, theta can take the values from 0 to pi, 0 to 180 degree. It can take 0 also, it can take 180 degree also. In that, suppose we see if vector A is equal to null vector or vector B is equal to null vector, then what happens to the theta value? Theta is not defined in that case, meaningless it will be. A is equal to null vector means there is only one vector is there, vector B. Here vector A is null vector, in the sense this is dot. We can't write the angle between dot and a line. If vector A is equal to null vector or vector B is equal to null vector, anyone is null vector, in the sense in that case theta is not at all defined. Okay, fine. This is about a definition. Let me write the definition once. Dot product of two vectors, dot product of two vectors A and B denoted by A dot B is defined as A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta, where theta is angle between A and B. If you write the definition this much, it is more than enough. Then what is A? A is magnitude and B magnitude of vector B, cos theta. Okay, we will write it. I will tell you something about it. What is this A, B and cos theta? See, suppose this is vector A and this is vector B, and this is a cos theta. If you drop the perpendicular here, if you drop the perpendicular here, let us take O, A, B, C like this it is. Now here you see cos theta is equal to what? Cos theta is equal to adjacent side by hypotenuse. Adjacent side is OA, by hypotenuse is a OC. Then OC is nothing but what? Cos theta is equal to OA by OC is length of vector B, that is magnitude of vector B. Then we can write OA length as magnitude of vector B into cos theta. Now here you see what is A dot B we are writing, what is the magnitude of A and B we are writing. A dot B product is nothing but magnitude of vector A into magnitude of vector B into cos theta. See, OA into magnitude of this vector is nothing but A dot B. This is what geometrical meaning is. And what is this OA is called as? OA is called as projection of B on A. OA is like a shadow of the vector B on vector A. So this is shadow into product of into the magnitude of the vector is A dot B. Okay. Now let us go with the observations. We are going to deal with observations. Observations of what? Observations of A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. First observation we will write here. See, I will write here A dot B is a real number. A dot B is a real number or it is a scalar quantity. Product of two vectors is giving us a scalar quantity here. How is this? See, A dot B is equal to magnitude of vector B, magnitude of vector A, it is a scalar quantity, and magnitude of vector B, again it is a scalar quantity. Cos theta is equal to some real number only, again it is a product of real numbers, means it is a scalar quantity. A dot B gives us scalar quantity, that is one thing, first observation. And now what about the second observation? Second observation we can write like using this concept, A dot B is equal to magnitude of A into magnitude of B into cos theta. Suppose theta is unknown to us. Can we find out the theta? Angle between two vectors. They may ask you the question like angle between two vectors. Cos theta is equal to A dot B by magnitude of A into magnitude of B. What is this? This is the angle between two vectors. Then theta is equal to, you can write cos inverse of this A dot B divided by magnitude of vector A into magnitude of vector B, like this we can write, that is angle between two vectors. Angle between two vectors. This dot product of two vectors definition we are rewriting to find out the angle between two vectors. You can use this as a standard formula. Now going to the third observation. Going to the third observation, that is A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. A dot B is equal to 0 in only two cases. What are those? A dot B is equal to 0 when first one is either vector A is equal to 0 or vector B is equal to 0. If vector A is equal to null vector, 0 vector, then its magnitude will be 0. As its magnitude is 0, 0 into anything will be 0, means A dot B is equal to 0 when vector A is equal to null vector or vector B is equal to null vector. And is there any other possibility? Yes, there is another one possibility, that is second one, when theta is equal to pi by 2, theta is equal to pi by 2, theta is equal to 90 degree. What is cos 90 degree value? Cos 90 degree value is 0. Therefore, A dot B is equal to 0. How vectors here will be? Vectors will be perpendicular to each other. This is 90 degree, here vector A and here is vector B. In this case, dot product will be 0. A dot B will be equal to 0. Means vector A is perpendicular to vector B. This is the one of the concept to use whether the vectors are perpendicular to each other or not. A dot B is 0 means vectors are perpendicular to each other. If they ask you, if the question is like verify whether the given vectors are perpendicular to each other or not, just you find out the dot product of those two. If the value is 0, then the vectors are perpendicular to each other. Next, suppose theta is equal to 0, what happens? Fourth observation, theta is equal to 0, what happens here? It means magnitude of, A dot B is equal to magnitude of vector A into magnitude of vector B. What does it mean actually? Theta is equal to 0 means both the vectors are getting overlap here, vector A and vector B, both the vectors are getting overlap on one second. Angle between them will be 0, theta is equal to 0. In that case, vector A dot B vectors is equal to magnitude of vector A into magnitude of vector B. Theta is equal to 0 degree here. And then in particular, I want to say one thing here. In particular, suppose we are taking A dot A only. Suppose we are taking A dot A. What does it mean? A dot A, here is A, here itself is A, angle between them will be 0 degree. So, this is magnitude of vector A into magnitude of vector A into cos 0, cos 0 value is 1. So, magnitude of vector A into magnitude of vector A is magnitude of vector A square. You remember this concept, A dot A is equal to magnitude of vector A square, A dot A is equal to magnitude of vector A square. And now, under this observation, I want to say one thing. Suppose theta is equal to pi. Suppose theta is equal to pi, 180 degree. Means one vector is, if one vector is from right to left, another one vector will be left to right, isn't it? Because angle between them has to be 180 degree. Theta is equal to pi. In that case, what happens? Let us see. A dot B is equal to magnitude of vector A into magnitude of vector B into cos pi. Cos pi is 180 degree, cos of 180 degree value is a minus 1. Here we write magnitude of vector A into magnitude of vector B into minus 1. So, we have A dot B is equal to minus of magnitude of vector A into magnitude of vector B. This is the case when theta is equal to 180 degree. In particular, I want to say one thing here. In particular, what is A dot minus of vector A? What is A dot minus of vector A? That means what? That means A is, if it is from left to right, minus of vector A will be from right to left, opposite direction. In that case, we should remember this is minus of magnitude of vector A square. Why? Because theta is equal to 180 degree, theta is equal to um, pi here. See, one vector A and another one vector is also A, but it is multiplied with a minus. Angle between A and A here is 180 degree. Two vectors are there. You have to be careful. A dot A is equal to minus of magnitude of A square. Theta is 180 degree in that case. Now going to fifth observation. Fifth observation is, suppose we have A dot B. A dot B is equal to, what is this? This is magnitude of vector A into magnitude of vector B into cos theta. Suppose I interchange magnitude of vector A and magnitude of vector B, anything wrong? No, nothing wrong, because these are all scalar values. Magnitude of B into magnitude of A into cos theta. What is this magnitude of B into magnitude of A into cos theta? This is nothing but B dot A. A dot B is equal to B dot A. I hope you know one property. Suppose we have 2 plus 3 is equal to 3 plus 2. Yes, it is correct. What is this? What is this property is called as? This property is called as commutative property, commutative law. In the same way, A dot B is equal to B dot A, we are getting, that means dot product of two vectors is commutative. I can write here dot product of two vectors, dot product of two vectors is commutative. Dot product of two vectors is commutative. Fifth observation got over. Now we will move on to the sixth observation. Sixth observation is, you see, suppose we have a dot, let us take the heading here, that is dot product of unit vectors. Dot product of unit vectors we are taking. Unit vectors means what are those? Unit vectors means I, j, k. I is a unit vector along the x axis, j is the unit vector along the y axis, and k is the unit vector along the z axis. We are taking a dot product of those vectors. What happens to this? What will be I dot I? What will be I dot I? I dot I is what? I dot I, magnitude of I into magnitude of I, that 1 into 1, cos theta. Cos theta is what? Cos theta is I and I in the sense theta is equal to 0, cos 0 is 1. So we have I dot I as 1. In the same way, what is j dot j? Dot product of j and j, dot product of two vectors is again 1 only. Magnitude of j into magnitude of j into cos 0, that is 1. Next, what about k dot k? K dot k is also same way 1. Fine, we wrote this one. What about I dot j? What about I dot j? I is a unit vector along the x axis, j is a unit vector along the y axis. What is the angle between those I and j? Angle between those I and j is 90 degree. So here magnitude of I into magnitude of j into cos 90. Cos 90 is 0. We have I dot j is equal to 0. In the same way, what is j dot k? J dot k is also 0. And what about the k dot I? K dot I, angle between k and I is also 90 degree. So k dot I is equal to 0. Yes. Now, yes, with this almost all the observations got over. Now, properties of dot product of two vectors. Properties. properties of dot product of two vectors. What are the properties? You see, first one I will say distributive law. Just there is no derivation for this, just they have mentioned it. Distributive law is if A, B and C are three vectors, if A, B and C are three vectors, then A dot B plus C is equal to A dot product with B plus C. Then shall I take here A dot B plus A dot C? Yes, we can take like this because this is the distributive law. Distributive law is valid in case of a dot product of two vectors. Or instead of that, if I have B dot C minus C, shall I apply this? Yes, we can apply B dot C minus of B dot A. We can write A dot B also because we know that dot product of two vectors is a commutative. Yes, fine. This is about a distributive law. Now, second one more thing. If A and B are two vectors, if A and B are two vectors and lambda is a scalar and lambda is a scalar, then we have lambda times A dot B is equal to lambda times A dot B is equal to lambda is getting multiplied with both. Here this lambda can be multiplied with only vector A or it can be multiplied with only vector B. Answers will be same only. So this can be taken as lambda times vector A, which is dot product with the vector B. Like this we can write, no problem, answers will be same. And instead of multiplying with the vector A, we can multiply with the vector B also. This is equal to vector A dot product with lambda times vector B. Like this also we can write. These are the two properties of dot product of two vectors. Next, one more important concept I want to say here, that is, see definition, that is A dot B is equal to A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. This one you should use when the vectors are given, okay, and direct vectors are given, like 2 times vector A, 3 times vector, like that. If it is given, then we will use this. Suppose the vectors are given in component form, means I plus 2j plus 3k, like that. If it is given, then what happens to the A dot B? We are going to derive it. Dot product of heading I am writing dot product of two vectors, dot product of two vectors in component form, dot product of two vectors in a component form. Let A is equal to vector A is equal to A1i plus A2j plus A3k and vector B is equal to B1i plus B2j plus B3k are two given vectors, Then what is A dot B is equal to? What happens to the A dot B? We are going to find. Important one it is. We will use this many times. A dot B is equal to, A is what? A is A1i plus A2j plus A3k, which is in dot product with the vector B is B1i plus B2j plus B3k. We know that dot product of two vectors, it is in case of dot product of two vectors, distributive law is valid. As distributive law is valid, we will write here A1i which is in dot product with B1i plus B2j plus B3k in the same way, plus of, now this second one, A2j which is in dot product with B1i, B2j, B3k. Next, plus of this A3k, A3k is in dot product with the second vector B1i, B2j plus B3k. Yes. Now, dot product as it is distributive, we will take the dot product with A1i and B1i. What happens to this? A1i dot product with B1i. As we studied the properties of dot product of two vectors, where lambda can be taken out. In the same way, here what are these A1 and B1? A1 and B1 are constants. A1 and B1 are scalars. So here I will write, instead of writing A1i dot B1i, we will write it as A1 B1 into I dot I. A1 B1 into I dot I plus of. Next, A1i is in dot product with B2j. A1 and B2 are scalar quantities. Let us write outside. A1 B2 into I dot j. Next, plus of, here A1 is in dot product, A1i is in dot product with the B3j. So A1 B3 which is in dot product with the I dot k. Next, plus of, here in the same way A2 B1, I write it outside, j is in dot product with I. Next, plus A2 B2 j dot j plus A2 B3 j dot k. Next, plus of, third one, distributive law, A3 B1 k dot I plus A3 B2 k dot j plus A3 B3 k dot k. Now, while going with the observations of dot product of two vectors, we have studied as A1 B1, I will be as it is, we have studied as I dot I. What is I dot I? I dot I, magnitude of I into magnitude of I into cos 0, cos 0 is 1. So I dot I is 1 plus of A1 B2 into, what is this I dot j? I dot j, angle between I and j is 90 degree, cos 90 is 0. So we will write here A1 B2 into 0 is 0. In the same way, I dot k is there 0, j dot I is there 0. A2 B2 into j dot j is 1 plus of, next it is 0, 0, 0. A3 B3 into k dot k is 1. We will write here, this is A1 B1 plus A2 B2 plus A3 B3. What is this? This is A dot B is equal to, A dot B is equal to A1 B1 plus A2 B2 plus A3 B3, where vector A is A1i plus A2j plus A3k and vector B is B1i plus B2j plus B3k. What is happening here? You just to see, they are multiplying the corresponding components, that's all. They are multiplying corresponding component. Here I component is A1, here I component is B1. A1 into B1 plus of, next. Here j component is A2, here j component is B2. They are multiplying A2 and B2, A2 into B2 plus of, next k component A3 B3. So A3 into B3. Very important one it is. Suppose two vectors are given in component form, then their dot product will be multiplying the corresponding components and taking sum of all those products. Thank you. In the next class, we will continue with the problems on dot product of two vectors. Thank you.